Warm greetings, dear students. Today the class is on respiratory system and mechanics of respiration. The objectives of this session: at the end of the session, the student should be able to enumerate the structures of a respiratory system, list the respiratory and non-respiratory functions, enumerate the inspiratory and expiratory muscles, and define intrapleural, intraalveolar and transpulmonary pressures. What is respiration? You all know the tissues require oxygen and carbon dioxide is released from the tissues. The metabolic activity produces carbon dioxide, and lung is the organ which takes in oxygen and moves out carbon dioxide. So what is respiration? It is just movement of oxygen in and carbon dioxide out of the lung is respiration, or utilization of oxygen at the tissue level and release of carbon dioxide in the tissue level is respiration. You have two types of respiration. You call external respiration and internal respiration. External respiration is just movement of air across the lung, and internal respiration is utilization of oxygen and release of carbon dioxide at the tissue level. So respiration comprises of, it is a process including pulmonary ventilation, where the movement of the thoracic cage causes expansion of the lung, causing movement of air inside the lung, and when the thoracic cage relaxes, the air is moving out. This process of movement of air in and out is called as pulmonary ventilation. Diffusion of oxygen and carbon dioxide across the lung and transport of oxygen and carbon dioxide by the blood is again important for movement of oxygen and carbon dioxide from the lungs to the tissues. So here you have ventilation, which takes oxygen inside the lung and releases carbon dioxide out. Here in the lung you have the pulmonary capillaries surrounding the alveoli. So here gas exchange occurs. Once gas exchange occurs, the oxygenated blood is taken to the systemic circulation and this oxygen reaches the tissue. So the lung with the circulation will be important in diffusion of oxygen and carbon dioxide and transport of this oxygen and carbon dioxide to the tissues. Then comes your regulation of respiration. The respiratory centers are located in the medulla, and regulation of respiration is for the movement of your thoracic cage and the circulation. So what is there in the respiratory system? You have an upper respiratory tract which comprises of nasal cavity, pharynx and larynx, and a lower respiratory tract where you have the trachea. The trachea divides into the two major bronchi. These two major bronchi in turn progressively branch into the primary and secondary bronchi. Then you have the bronchioles, and then you have the alveolar ducts and the alveoli. So the respiratory system has a conducting airway which has oral and nasal cavities, the pharynx, larynx and trachea, the lung which has the bronchi which again branches into your bronchioles. There are 23 generations of branching from the primary bronchi till your alveoli. So the structures of ventilation, mainly the rib cage which keeps the lung within it in a protected state, and the respiratory muscles that are important for the movement of the rib cage. You have the central nervous system which controls all the activities and the nerves supplying the respiratory system. All together is very important for effective functioning of the respiratory system. So this picture shows the branching of the tracheobronchial tree. You call this as Weber's tracheobronchial branching system. Okay. So here you have the right and the left bronchi. These are the two major bronchus which will branch into multiple branches. You have 23 generations of such branching. Up to the 16th generation of branching, you call that as the conduction zone. The bronchi branches into bronchioles. These bronchioles will form the terminal bronchioles. Then comes the transitional bronchioles. After the 16th generation of branching, you have the respiratory bronchioles. Here, the respiratory bronchioles are there, will have few alveolar sacs. Okay. The respiratory bronchioles further will divide into alveolar ducts and alveolar sacs. The alveolar ducts and alveolar sacs will have large number of alveoli. These alveoli are the areas of gas exchange. The conduction zone from the first generation till your 16th generation does not have any alveoli. They just conduct the air from the upper respiratory tract to the respiratory alveoli. Okay. So, these will form what is called as dead space. Dead space will be because of this conducting zone. Okay. So, coming to the respiratory bronchioles, the respiratory bronchioles will have the alveoli attached to it. It is here you have the gas exchange. As the bronchi branches into bronchioles, the total surface area of the bronchioles will be increasing. The total surface area is increasing, so there will be decrease in the pressure. The decrease in pressure is because as we branch more and more, as the bronchi branches more and more, there is fall in pressure and easily air can flow. The resistance to flow is very, very less. The maximum resistance to airflow is seen in the larger bronchi. Maximum resistance to airflow will be there in the larger bronchi. And as the total cross-sectional area increases progressively, there is more easy flow of air across the lung.